In this problem, we've got this transverse wave, which is described by this equation here, and we're asked a couple of questions about it. Well, it's important to be able to pick apart what this means. So for example, for Vy, if we're finding the transverse velocity, what they're really asking for is the velocity equation would be negative W times the amplitude times cosine. And then there's going to be a K, that's the wave number there. And then we've got an X. And then we have a plus or minus, the WT, plus some phase constant. Now, by comparing these two equations, this is what the velocity is. But if we compare these two, we'll figure out that, hey, look, this looks pretty similar. So we actually can figure out that the wave number is pi over 12. And then we can see that the W is 3 pi. And we don't have a phase constant, so that's nice. The amplitude is actually this, because this is the x base. This is the distance, or this is velocity, and so this would not have a w. Like this has a w because we had to take a derivative here, but this is not going to have w, so we can just immediately pull out the a is equal to 0.115 right there. Okay, and for the w, we already know it. So we basically can answer this first question by plugging in these answers. Now, they're asking for the speed here, the transverse speed, so we wouldn't even need to consider this minus. And one last thing, if we look at this plus sign right here, we should also know it would be a plus version of this equation. So we've got everything under control here. Let's plug it in. We basically say like 3 pi, and then we'd have our amplitude, and then there'd be cosine, and then just a pi over 12. The x is given to us, 1.3. So you plug that in there. It's a plus sign. And then we have the w, which is going to be 3 pi. And the t is given, it's 0.13. And then there's not a phase constant there. So we've kind of closed this off. And if you try to solve that in the calculator for Vy, that would come out to be a really small number. So let's just put that right over here. It would be 0.005675, something like that. So this would be the Vy. It's our first answer for A. Now for B, they're asking for the acceleration version, which would be pretty similar, but it would essentially be like W squared. Of course, you'd have a negative here. Then you have the A. We're looking at a sign again, and then I think everything else is the same, so you still have the K and the X. This is still plus. We'll just kind of simplify this a little bit, so something like that. If we plug in these numbers, it would be negative. When you take the W squared, try to square 3 pi, it would be like 9 pi squared in the calculator. And then you'd still have the 0.115. You'd have the sign of a pi over 12. It's still 1.3. It's still plus 3 pi, 0.13. And so when you plug that into the calculator, you should get an answer of about negative 10.215 meters per second squared. And so that would be what the AY is. This is for B. Now they're asking for this wavelength, and we know that the wave number is equal to 2 pi over the wavelength. And if the wave number is pi over 12, that would be equal to pi over 12, then you could see that you can multiply this by 2, and you kind of get like 2 pi over 24. And so we can see that the wavelength is 24. So that's our wavelength. For the period, well, we have this equation that W equals 2 pi over T. And so since we know W is 3 pi, 2 pi over T, and you kind of rearrange that, and you get that T equals 0.667, or 2/3. And for the velocity, well, the velocity is going to be equal to W over the K number. And so that should just be 3 pi divided by pi over 12. And that would turn out to be 36. So that is going to be the speed. Cool.